Hello. I decided to try to solve this cable tension problem that I saw posted. It didn't give a diagram, so I've made up a diagram here. And this is a fairly common problem that you'll see in physics for equilibrium problems. So the first thing that you'll want to do is draw a free body diagram. So I'm going to think about all of the forces that are pulling on this point here. So we have this tension force going up and to the left is T1, and a tension force going up and to the right is T2. And then the sign is pulling down with the weight of the sign. We'll just call it T3. To relate all of these forces, we're going to have to break them down into their left, right, and up, down parts. So tension 1, for example, is pulling to the left and pulling up this way. Tension 2 is pulling to the right and also pulling up. I like to call the left-right part sub x, so tension 1x, call this tension 1y, call this tension 2x, tension 2y. Now, because nothing is moving or speeding up or anything like that, we know that the left and the right tension must be equal. So I can say tension 1x equals tension 2x. And we need to figure out tension 1x using a little bit of trigonometry. So if we go in here and draw the angle, this angle here is the 61.9, and this angle is 37.1. So thinking about my trig functions from the perspective of the angle, we want the adjacent side and the hypotenuse. So that's cosine. So cosine 61.9 is equal to the adjacent side, T1x, divided by the hypotenuse, T1. So now we have T1x as T1 times the cosine of 61.9, which is equal to T2x. We can get that in a similar way. So that's just going to be T2 times the cosine 37.1. T1 we're given is 320.51. So we can solve for T2 now with everything else filled in. Put that in the calculator, we get 189.27 newtons. This problem also asks you about the mass of the sign. So if we can figure out T3, which is the weight, then we can get the mass. So similar idea, however hard T3 is pulling down must be equal to how hard T1y and T2y are pulling up. So we know that T3 is equal to T1y plus T2y. And the y values are going to be equal to the sine of the angle times the force, just like the x values were the cosine of the angle times the force. So T1y will just be T1 times the sine of the angle, 61.9. T2y will be T2, which we now know is 189.27, times the sine of its angle, 37.1. So we plug all that in and we get 396.90 newtons. So that's the weight. If you want to know the mass, you want to divide that by 9.8, or if you're really lazy like me, you could just divide it by 10. So the mass would be about, let's say about 39.7 kilograms. There you go.